At this point, we know about cloud deployment models and cloud service models. So how do we tie that into security exactly? Well, one way is by thinking about who is responsible for what. Now that's important because if I'm not responsible for something, I'm not responsible for securing it. So let's talk about that. So let's talk first from the perspective of the cloud service provider, or the CSP. What are their responsibilities as the provider of cloud services? They are responsible for everything related to the hardware in their data centers, because we as cloud customers don't have access to it unless it's a private cloud. But from a public cloud perspective, it's in a data center somewhere that's secured and I can't get into it. So that would mean the power to feed to those appliances, to servers, to routers, to storage arrays, HVAC, heating, ventilation, and air conditioning to keep equipment running smoothly and coolly. Also, configuration of the hardware, firmware updates. It's all the cloud provider's responsibility. Now you might be wondering, well, wait a second though, isn't the cloud service provider sometimes responsible for software? And you would be right. Yes, they are. Sometimes. It depends on the cloud service model. So when it comes to platform as a service, such as deploying a database in the cloud, the cloud service provider is responsible for the underlying virtual machine for that and the database software. You would only be responsible as a cloud tenant for the database config. Also, software as a service, or SaaS. All of the underlying hardware we already know is a responsibility of the cloud provider, but so is that particular software service offering, such as, example, making the interface and the mail system work for things like Gmail or for Hotmail or Outlook.com or Microsoft 365. The only thing we as cloud customers are responsible for is how we configure some of the settings in those apps and then how we actually use it. So let's focus for a moment on our responsibility as cloud customers or cloud tenants. First of all, if we're talking about the public cloud, how do you get there in the first place? Presumably over the internet. Well, if you rely on that for mission critical services that are running in the cloud, not on your network, what's going to happen if there's an internet outage with your internet service provider? You lose access to that stuff. That might be unacceptable. So remember we talked about risk management a long time ago, and we were talking about business impact analysis. That's a risk that we would lose internet connectivity. What would the impact be if we've got mission critical services running? Could be huge on the company. In which case, we might want to have more than one way to get to the public cloud. That could come in many forms. It might mean that you have multiple internet connections, ideally from different internet service providers. Or you might have an internet connection to the public cloud, but you might also talk to your local telecommunications provider and have what's called a dedicated wide area network circuit directly into the cloud without going over the internet. The internet is certainly not the only way to get network traffic sent around the world. It's just the public one that everyone knows about. Another thing to think about is we can enable cross-region replication. For example, if we've deployed a storage account in the cloud, we can enable it to replicate to another alternate region so that if we have a regional outage, we already have the data that's been replicated to the secondary copy. So that increases high availability for that storage, or even for virtual machines if you replicate virtual machines across regions. Now, there are some cloud security controls that are really specific to a cloud computing environment, including terminology that's going to be important for the Security Plus exam. The first term here is a Cloud Access Security Broker, otherwise called a CASB. What is this? Well, this is a software security component that enforces security policies when you've got users accessing cloud resources. Now, normally this comes in the form of a virtual machine appliance that runs on premises, and essentially it acts as a middleman. It acts as a proxy between clients on premises that are accessing services in, for instance, the public cloud. Now, what might it do? Well, it might restrict which type of virtual machines can be deployed, or it might limit how big storage accounts can be that are deployed into the cloud. Or it might also have threat detection. If you're uploading files into the cloud, it might scan those files to make sure they're not infected. Now, this is important because you can imagine in the Security Plus exam, if you get a question and one of the answers is a CASB, if you don't know what that is, how could you possibly answer that question properly. So having this terminology in mind is going to be very important for Security Plus. Just like a next generation secure web gateway called an SWG. This essentially is a security appliance that has CASB functionality that we just talked about, but additional capabilities like web content filtering, maybe to limit which apps can be visited or which websites can be visited, standard firewall stuff. Also things like data loss prevention, DLP. DLP policies, you might remember, are designed to prevent unauthorized data exfiltration, sensitive data in the company being provided outside of the company to unauthorized individuals. Now, depending on the cloud service provider you're using in terms of a public cloud will determine which specific firewall offerings they have. In the Microsoft Azure cloud, for example, we have network security groups or NSGs. Essentially what these are layer 4 packet filtering firewalls to allow or deny traffic into or out of a virtual machine or a network in the cloud. Then we can have policies that we configure in a cloud environment. An example would be Azure Policy. It's called Policy Singular. The idea is that with cloud policies, we can do things like limit how resources are deployed. For example, I'm going to implement a policy that ensures that when cloud technicians deploy a virtual machine, it's using a custom image that's hardened, and it has to be replicated to a secondary region for high availability. A policy can enforce that. A policy might also be used to check compliance. Do we have virtual machines hardened in alignment with the PCI DSS cardholder information security standard? We can have that done automatically, a compliance check essentially. We know that data loss prevention, or DLP, prevents data exfiltration. Well, we can do that in the cloud directly itself, such as with Azure Information Protection, or AIP. Pictured on the screen, we have an example of data loss prevention in a cloud computing environment. If we take a look at the details in this example, it's talking about blocking people from sharing and restrict access to shared content. Well, what's the context here? Well, if we look further down at the second radio button selection, it says block these people from accessing SharePoint, OneDrive, and Teams content, Microsoft Teams. And the selection is only people outside the organization will be blocked. People inside your organization will continue to have access. This is a simple example of a data loss prevention policy that affects who can access what in a cloud computing environment. So let's take a look at the Microsoft Azure cloud. More specifically, what I want to do is look at policy compliance. Okay, so here in the Azure portal, I'm going to search in the very top search bar for the word policy, and I'll click on policy. That shows up in the results list. That opens up a new web page which lets me manage Azure policy. Now, I've already got a policy assignment that I've created beforehand, so I have the result of that compliance check in the compliance view on the left. So for instance, if I look at what we've got here, I have a policy that is really checking that disk encryption is enabled or applied on virtual machines. And what I'm seeing here is it says non-compliant. Uh-oh, that means I must have virtual machines in the cloud here that don't have disks encrypted. Of course, that's why it says non-compliant. My question is, who are the offenders? Easy. We can just click directly on the link for that compliance, and we'll see the names of the virtual machines that really need our attention because the disks aren't encrypted. As I scroll down, oh boy, it's pretty much all of the virtual machines in my subscription. I guess we have some work to do to harden that aspect of the cloud. The last aspect of cloud security is cloud monitoring. If you aren't monitoring what's happening to your cloud services, whichever ones you select to use, how can you know if there are abnormalities or suspicious activity? So you need to monitor things like who is deploying virtual machines. That's more on the auditing side. You need to be able to monitor any apps that might be running in virtual machines. You can also review logs. Now, everything has a log, whether it's a virtual machine running in the cloud, whether it's a storage account in the cloud or a database. So it's important to be able to access those logs to see what's happening. But really, do you want to spend your days going and looking at logs, seeking out anomalies? Of course not. Instead, we should use log forwarding, which we've already talked about because it applies in the cloud too. so that all of that log information is aggregated in one central log monitoring vestibule, so to speak. And in the Microsoft Azure cloud, that's called Azure Monitor.